Hello everyone, today we're gonna prove the famous product rule, okay? Now you may have seen some proofs before. There is something tricky that we need to do in one step of the proof, but I'm gonna try to explain it as simple as possible so you're not confused about anything, okay? So let's begin. Now we know that if we wanna prove the product rule, we need to prove this equation. And if we wanna prove this equation, well, we wanna begin by doing something different with the left side. So we know that if we wanna take the derivative with respect to x, for two functions f of x and g of x, you know, the product between them, you can use the derivative definition, okay? So you're going to have the limit as h approaches 0 for f of x plus h times g of x plus h, okay? Don't forget to add the h in the two inputs, minus the initial values for these functions, which are going to be f of x and g of x, okay? And this entire thing is going to be divided by h. Okay, nice. Now we want to write something. So we want to write something new so that we can play the algebra in this quotient. Okay, here if we have this form, we cannot really do anything. So we need to write new terms so that we can factor things out and start playing. So that's what we're going to do. So we have that this is equal to the limit as h approaches 0 for. Now pay attention to what I'm going to do. F of x plus h times g of x plus h. And now I'm going to write something new. I'm going to say that we have plus f of x times g of x plus h minus f of x times g of x plus h, okay? And now we want to write the same thing, the other black term that we have, the other term in black. So this is going to be this, okay? Now, what just happened? You might be wondering. Now, see it by use the colors to guide yourselves through what just happened. So we have the first product between the two functions with the h, that is over here. Now we also have the initial values for f and g, which is over here, and we have in the middle new terms that are going to allow us to play, to use factoring to find different limits, and we're gonna be able to prove the product rule doing that. So basically, these terms that we have in here, first, you can see that they don't change the initial limit that we had at all, okay? They have different signs, so they're gonna cancel out each other, okay? F times g of x plus h, it has, it's the same term here, but they have different signs, so they're gonna cancel out, and that is gonna be equal to 0, so you're not gonna be doing anything to the initial limit. But there is something pretty cool that these two terms will allow us to do. Okay, so this thing is over h. Now, what we're going to do is we're going to factor out common factors. So we know this is the limit as h approaches 0 for f of x. Now, I'm going to factor now. So you can see that we have common factors. One of them is this one, g of x plus h, and this one over here, g of x plus h. And actually, we're not going to use this one in here, but the one with the negative sign, and you're going to see why, okay? I'm going to tell you in a moment. We're going to use these two g of x plus h's. So we want this one, and we're going to take it out from these two terms, okay? And I'm going to do that in blue, yep. So we have g of x plus h times, I'm going to do like this, times f of x plus h minus f of x, okay? And now, well, we're going to do the same thing with the other two terms. But in this case, the common factor that we're going to take out is going to be f of x. So it's going to be this one and this one, okay? So yeah, let's do that, and we're going to take out f of x with a positive sign, yep. So we have plus, once again, f of x times, and we have over here g of x plus h minus g of x, okay? This is what we have. And all of this is going to be divided by h, and I believe now you might be able to see why I needed the negative sign for, why I used this g of x plus h and not this one. So if you see that this entire thing is divided by h, you can see that this h, you can distribute it to both terms. And it turns out that on this side, well, we have, if you put h dividing this, you're going to have the derivative of f. And I needed to choose g of x plus h and negative g of x plus h on this term in order to get f of x plus h minus f of x. Because if I had used this term, well, I would have gotten, taking out g of x plus h on these two terms, it would have been g of x plus h times f of x plus h plus f of x. And I don't need that because I want to be able to write the derivative definitions for f and g. You can see that if I distribute h into these two terms, well, I'm going to get the derivatives for those two functions, and you're going to see what happens next. So that's what we're going to do. And I'm going to do that over here. So we know this is going to be the limit as h approaches 0 for g of x. And actually, I'm not going to have enough space, so I'm going to continue down here. Yep. So this is going to be the limit as h approaches 0 for, so we have g of x plus h times f of x, you know, the difference quotient, minus f of x over h, okay? And now I believe you know what we can do with that term. We can simplify it. So you have plus f of x times g of x plus h minus g of x, okay? And this over h. And now we have these two limits to compute. Now you know that if you have g of x plus h and h is approaching 0, it is a very small number. That number added to x is not going to do absolutely anything. Okay, so we know this factor is just going to turn into g of x. Okay. Now this limit, well, you can see that this is the quotient for the derivative of f. So you can write this as f prime of x, okay? Plus f of x. And now you know this is the derivative of g, okay? So you know this is just simply g prime of f. And this is the famous product rule that you've seen before, okay? And well, this is the entire derivation or proof, if you want to call it like that, of this equation right there, okay? It is pretty cool, it is pretty simple. The only thing that you need to be careful is when you write these two blue terms, and when you factor out, remember that you want to create the quotients for the derivatives of f and g. And if you don't do that, well, you're gonna screw it up because you're not gonna be able to get the correct signs, okay? And well, you're not gonna get derivatives here, but simply two terms being added, and that's not gonna work out. So well, yeah, I hope you have enjoyed this video, learned something, and I hope to see you in the following video. Yeah, bye.